Hello friends. In this video we will discuss about VLAN hopping attack. Okay. So what is VLAN hopping attack? To understand it, let's go through with the diagram here. We have switch 1 connected with switch 2, switch 1, switch 1, switch 2, and we are using 802.1q as a trunking protocol. We have here VLAN 10 user, 20 user, VLAN 10 user, and 20 user. This is VLAN 10, this is VLAN 20, and by default we have VLAN 1 here, and in VLAN 1 we have a user here. When we are talking about VLAN hopping attack, before this we should remember some points here. First point, only from native VLAN dual tag. 1 minute. Only from native VLAN dual tag frames are allowed. Okay, only from native VLAN dual tag frames are allowed. And second point is here, for native VLAN there is for native VLAN no need of VLAN tag. That's it. VLAN 10, VLAN 20. By default, VLAN 1 is equal to native VLAN. VLAN 1 is equal to native VLAN, and for native VLAN, no need of tag, no need of tag. When a switch will receive untagged frame for native VLAN, which is VLAN 1. Done. Now what will happen here? Only from native VLAN dual tag frames are allowed. If any user of VLAN 10 of VLAN 10 or 20, they will send a frame with dual tag like 10 and 20. If this frame will be arrive here, frame will be dropped because only from native VLAN dual tags frames are allowed. If 10 and 20, they will send dual tag frame that will be drop here. Okay. Now VLAN 10, VLAN 20. Okay. Now what will happen? We also have a user in VLAN 1. When this host will send a frame, that frame will arrive at switch. Switch will see frame is coming from VLAN 1, which is native, no need of tag. Then this frame will be forwarded as it is to switch 2. Switch 2 will see untagged frame first of all. When frame will be received by a switch, switch will start the logic. Traffic is coming from VLAN 1, which is native, for native no need of tag. When there is no need of tag, then forward the frame to switch 2. Switch 2 will receive untagged frame. Untagged frame is for native VLAN, and for native VLAN, then the frame will be forwarded to VLAN 1 by default. VLAN 1 here. Now this is 10 for example, and this is our VLAN 20. Now traffic came from VLAN 1. Now it was forwarded in VLAN 1. This will happen. Again, I can repeat. Traffic will be initiated by VLAN 1 user. Frame will go to switch. Switch will receive the traffic from VLAN 1. Then switch will start logic. It is VLAN 1. It is native VLAN for native VLAN. Then no need of tag. No need of tag. Send the frame as it is to switch 2. Switch 2 will receive untagged frame. Untagged frame is for native VLAN. Native VLAN is here VLAN 1. Then forward the frame into VLAN 1. This will happen in this way. Now normal behavior, but assume this user is not normal user here. This is an attacker. Okay. This is an attacker. We have separated the resources in VLAN 1, in VLAN 10 and 20. We don't want that this user should be able to access 10 and 20 resources. That's why we created multiple VLANs here. Now this user will create, this user belongs to, yes, this user belongs to VLAN 1. Okay. Done. The attacker is in VLAN 1, and which is, we can see here, native VLAN. Native VLAN or VLAN 1. 1 minute. By default, VLAN 1 is native VLAN. Done. Now what will happen? This attacker wants to create a disturbance in VLAN 10 and 20. How it can do? This will generate a frame. In frame, it will add dual tag. This is our frame. Okay, this is our 1 minute. This is our frame. Then frame will be encapsulated with dual tag. It wants to go to like 10, and then it will encapsulate the frame with 1. Now how many tags are coming? 2, 1 and 10. Now this frame will be received. Okay, now 1 minute. You will say it is not good representation. Okay, no problem. We have a frame. Frame contain 2 tag. It wants to go to 10 and as well as 1. This frame will be received by switch 1. Only from native VLAN dual tag frames are allowed. Attacker crafted or Attacker will generate a dual tag frame. That dual tag frame will be forwarded to switch. Switch 2 will accept it. Okay, now switch 2 will start logic. Traffic is coming. Frame, dual tag frame generated, forwarded to switch. Switch 2 will accept it because only from native VLAN dual tag frames are allowed. And for native VLAN, no need of VLAN tag. Now, first step, second step, the traffic is coming from VLAN 1, which is a native VLAN, which is a native VLAN, and fifth step is here, no need of tag. Then switch, this switch will remove the first tag here, frame 10, frame with tag 10, frame with tag 10 and 1. Then what this switch will do? Switch 2 will no need of tag. For native VLAN, no need of tag. Then switch will remove the first tag here. Now frame contain tag number 10. Now switch 1 will forward this frame into VLAN 10. One copy will go to switch, and then the frame will be forwarded based on tag in VLAN 10. Frame was originated from VLAN 1. Now it is in VLAN tag. So only from due to the behavior only from native VLAN dual tag frames are allowed, and for native VLAN no need of tag. When an attacker which is in native VLAN, if that will send dual tag frame, that will be accepted by switch. Switch will consider it is coming from VLAN 1, which is native, no need of tag. Switch will remove the first tag now, or switch will remove native VLAN tag. Now tag is 10. Then based on tag 10, the frame will be forwarded into VLAN 10. This condition is called here VLAN hopping attack. What is the solution of this? VLAN hopping attack solution is change native VLAN, change native VLAN, change native VLAN. Now what we need to do? We need to create a VLAN like 420, okay? 420, and same here 420. We need to create a VLAN. We need to synchronize that VLAN on all the switches. Then we will define every switch native VLAN is equal to 420, native VLAN is equal to 420. Okay, now VLAN 1 is not native. Now VLAN 1 is not native. VLAN 420 is native VLAN. Now 1 minute. Now VLAN 420 is native VLAN. Done. Only from native VLAN. Now VLAN 420 is the native VLAN. Dual tag frames are allowed. For native VLAN, no need of tag. Now VLAN 1 is normal. Now what will happen? If we will change the native VLAN here, then what will happen? Now VLAN 1 is a normal VLAN if VLAN 1 user if VLAN 1 user will send dual tag frame that will be dropped by switch. If now that will send dual tag frame, now drop the frame, because only from native VLAN dual tag frames are allowed. Now this is normal VLAN, dual tag frame will be drop here. Who can send dual tag frame? Dual tag frame can be sent by native VLAN, which is 420, but important thing is here, either we have host in VLAN 1 or 10 or 20, VLAN 1, 10 or 20, no user in VLAN 420, then no possibility of dual tag frame. So in this way, you can prevent your network from VLAN hopping attack by changing native VLAN. Thank you.